Hey guys, welcome back to the new video, and in this video we'll be talking about DOM, cross-site scripting, but not just the basics. You're going to understand how you can look for this one with these bug bounty hunting or pen testing. Also, we're going to talk about DOM Invader extension, which is an extension from the Portugal itself. So you can find it in the Burp browser. You just have to install it there and put the plugin in. But the thing is, a lot of people don't know how to actually use it or how to make the most out of it or what actually happens behind the scenes. Some of the people just only throw payloads and they think that they're gonna find DOM XSS, but that's not how it works, right? So in this video, we will break that down, what happens behind the scenes, how this actually works, so it will make sense to you and it'll be more clear to you. So hope you enjoy this video and let's get into it. So let's start with the basic introduction. What happens in cross-site scripting? Basically, you input something, a value, in an input field, which gets reflected in the browser or in the HTML page more technically. So basically, let's say there's a search field, you input something and that value gets reflected in the page. But if those values are reflected without being sanitized, for example, if you can include your own tags or script that gets reflected in the response, gets included, and then gets executed by the browser, then it's a cross-site scripting. Now, DOM XSS is pretty similar to reflected XSS, except there are two more things included there. First is source and sink. So the input gets in the source first, and then it is executed by the sink, which is a function. So sink take that, and then it does some processing. Now we'll talk about what are those sources and sinks. I'll show you example, so don't worry about that. Okay, but what's DOM in the first place? DOM stands for Document Object Model, and it helps the programmers to create, update, or include HTML elements dynamically on the web page. So this provides user-friendly interaction and makes the website dynamic. And as I mentioned, there are two things you need to know. First is source and second is sink. So source is where the input comes from, basically. But if you want to know the more technical view of it, like more technical way of saying it, a source is a JavaScript property that accepts user data. So this could include user input from forms, URL, or any other input fields like a comment section. Even could be a parameter or cookies that you find in the HTTP request. A really good example of source is location.search. So location.search takes the value from the query string. So every source has different way of taking the input value. Now there are a lot of sources similar to that, and I'll show you a few of them in a practical view. Also, we're going to look at few reports of DOM XSS as well, so you can understand it better. And the second one is sink. Sink is a function similar to what you see in programming languages, a function that takes parameters and perform an action on it. Similar to that, sink is a JavaScript function that performs an action. So basically it does processing on the input that you provided, so that is user controlled, aka attacker controlled, which comes from the source. So source takes the input and pass it to a dangerous sink. That's where the actual DOM XSS happens actually. So even if they're a source, it's fine, but if it's getting passed to a function, aka a sink, that is doing processing without any sanitization or anything and just executing the code, then it's a DOM XSS. For example, eval function. So this function executes the JavaScript code without any sanitization. That leads to DOM XSS. Another example of sink is inner HTML, document.body.inner HTML. It allows the HTML and JavaScript code to be included in the HTML body, and which gets executed by the browser, eventually leading to DOM XSS. So let me tell you something that will make a huge difference to you, like it will change your whole perspective of the DOM XSS compared to other XSS. Like in reflected and stored XSS, what happens is those input gets sent to the server. Like in stored XSS, your input gets stored in the database, and then from the database it gets back to the browser to put it up there, and which gets reflected in the browser. And in reflected XSS, it's again gets back sent to the server, and then the server loads that HTML page, and then since there is the XSS payload, it gets executed in the browser. So In reflected and in stored, your payload is getting sent to the server first, but that doesn't happen in DOM XSS. In DOM XSS, your payload is not being sent to the server, it's just get loads in the victim's browser. That's a very huge difference. It's not sent to the server, it's just get executed in the victim browser because the DOM updates it dynamically. I told you that's what the job of the DOM is, to update the elements of the HTML dynamically in the victim's browser. Nothing is sent to the server. So that's a pretty huge difference. You should definitely keep it in mind. To understand this better, we are going to look at this Bootsucker lab. So just to tell you how the DOM XSS works, I'm not going to show you a bunch of labs in this video because it's gonna be more practical than that. Okay, so here we have this lab and it says document object model XSS in document.write sync using source location.search. So I told you what location.search does. It takes user input from the query string. It means there has to be some kind of query in the address bar, or you can see it in the HTTP request as well. So let me turn on my network tab, and if I search any keyword, you can see there is this search parameter. Let me increase the size. Yeah, so you can see the search parameter and it has this value. So location.search is going to take the value from this search parameter because this is a query string, okay, and it's get HTTP method. Now this values goes somewhere which you cannot see directly. Okay, so let's go to debugger, and in the JS file, if you see, there is a function that is track search, and this takes a value that is query. So basically it's taking a parameter and then it uses document.write, which is a sync, to put this whole image tag in the HTML body, which you can see over here. Okay, you can also see the script here, but we got the better format of it. Anyways, we have this whole image tag, and then we have search terms equals query, and query is a dagger controlled value because this will get replaced to whatever value we added. In this case, we added JKK, so JKK will simply come up here. Now this is already dangerous because it is using document.write and it's probably doing it without any sanitization. So as you can see, we have this another variable query, which is again this parameter. So this query got passed over here, and window.location.search got the user value from the query string, and the query string name is search, so that's why we have this search written here, and the value of the query string was JKK, which gets stored in this query variable. Now this query variable gets passed to this function in the track search, and track search has this function, which is a JavaScript function, document.write, which eventually puts that value in the HTML body. I hope I'm not sounding alien, I just wanted to decode you, hope it makes sense. Well, let's try to add our payload here. Guys, can you ignore that congratulations, because I forgot to record that section and I solved the lab. Anyways, so let me tell you what happened. Like when you put your payload here, this is the exact payload that I use, and if you click on search, this is gonna get executed, but what happens in the backend? And if you look at it here, of course this is the most basic payload and there are tons of payloads that are way better than this, but this one is enough to solve the lab and to demonstrate you what just happened. Okay, you can see I close a tag here, which is with double quotes, and then closing tag, and then I included my own script tag, which got over here, and then it got executed by the browser. Simple. Now this happened because there was no sanitization from the document.write function. It just included that thing in the HTML body directly and then got executed. So you know how all of that happened because of this function and because it was a dangerous thing. But yeah, that's how it works. Now it's time to look at some reports, so you can get a real life example as well. So we have this first report. which was reported way back, but it's okay. DOM XSS is DOM XSS. Okay, that's the title. And we have this little summary. DOM XSS, called in some text type 0 XSS, is an XSS attack where the payload is executed as a result of modifying the DOM environment in the victim browser used by the original client-side script so that the client-side code runs in an unexpected manner. What a definition. Okay, so this is observed in this part. This is the endpoint. The value given in build and other get parameters are accessed by the client-side script and written on the page using document.write classic sync without output encoding. So look at this HTTP request. So this is the get request, and you can see we have this value build. So there are two get parameters, build and other, and there's some cookies and stuff. And in the response, we have this script document.write, which contains this value script src equals ui.build path, and then another script. So I think, so it's saying that the vulnerable client-side code in page COD. I think he meant code, not Call of Duty. Anyways, which will track back to script source. In switch, a default value has been set to build, which will be same as the user injected in the parameter. Okay. So in simple words, the value this get parameter you're seeing is user controlled. If you change the value there, it's gonna get included over here, and using the document.write function will be executed in the browser without any encoding. So you can see there's this function ui.buildPath. So as you can see, the payload gets executed over here, and you can see the payload value in this build parameter as well in the address bar. Now let's move on to another, which was reported to Uber. So saying, hi, I found DOM XSS on this subdomain eng.uber.com. You're using a vulnerable plugin, Pretty Photo. Okay, this XSS will work on Firefox, Chrome, Google, and IE last version, and this is very dangerous. So this is the Firefox vector. So it is included in the URL itself, it seems. We have to look at these images. It's downloaded. Okay, so you can see it's in the URL itself after the hash fragment, and then this on-click alert document.domain classic XSS payload. And this is Firefox. Really, dude? That's why I created that video, how to write reports. One of the classic example is this one. So it says that this Pretty Photo plugin has DOM XSS. Maybe we can search for it. DOM XSS. The WordPress Pretty Photo WordPress plugin was affected by DOM XSS security vulnerability. Okay, it's this one. Yes, that exactly is. Look at this payload. This is literally same. So yeah, you should definitely look for plugins out there as well. Okay, now you must be thinking, what's the source here? The source here is the, you can say, the URL fragment, because after this hash, he's including this whole payload. So this is a pretty old one, but that does set a reminder that we should also look for what kind of plugin the application is using, and maybe it could be vulnerable to some kind of vulnerabilities like DOM XSS in this case. And now we are looking at the last report, which is better than the previous two because this is very detailed and I love it. So this one is reported to GitLab in 2021. And the summary here says a clipboard DOM-based XSS exists on several markdown text fields. So this is actually a pretty huge report with a lot of details, which I love. But the thing is, I'm going to give you a short, quick idea, but with the details. I'm not going to read this whole thing because I don't want to waste your time. But what happens here is, in GitLab, when you paste something to the clipboard, like in the markdown, there are different MIME types you can paste it, like in text/HTML, or there's another tool mentioned in the source code, as you can see, text/xgfm or text/gfm HTML. So this one is actually the HTML version MIME type. So this is used so you can preserve the formatting when you paste something to the clipboard. The thing is, when you're pasting something to the clipboard like this, of course it should be like sanitized and look if it is encoded properly or not. But what happens in this case is, you can see data is copied from the clipboard and then which is included here. And let's look at the sink. The sink over here is pretty classic. It's actually inner.html, as you can see here. So inner.html contains this value gfm html, and gfm html is this. As you can see, the const is defined here, and this contains the value. Now, the user can paste anything which will go in this gfm html, and that gfm html get included in the div of the inner html. In the div tag with this inner HTML JavaScript function, and that includes the user value, right? And this get executed because it parses it without any encoding or any kind of output encoding, you can say. So if you look here, I think he created this whole POC, install the Docker container engine, and create a HTML file like the following. Okay. Clipboard XSS, paste it on the editor and see what happens. So we have this text/xgfm HTML, and then the XSS payload img src on error alert 1. Okay. Now what? Spin a new GitLab container with the following commands. So this is basically the command to spin up the GitLab container. And then using a web browser, navigate to the HTML file created in step 1, select the word here as instructed and copy it to the clipboard. Here, what's here? Now navigate to the URL and follow the instructions required to set up the password for the root user, basically setting up the GitLab instance. And click on the new issue button, paste the contents from the clipboard on the description text area, and check an alert box is displayed. Okay, so very nice of him to add the video POC. Click here to paste it on the editor and see what happens. Okay, so that's the POC created. So here we have the issues, and then the new issue button, and then here is the description. So this takes, I think, is a markdown. And if you paste this whole thing, this payload, it get executed over here. This is actually pretty complex, not that simple. But I'm not really a genius at GitLab, but I'm getting the idea what's going on here. That's really good level of research he did to find this bug. Now, the most clever part here is you must be thinking why he's creating that whole HTML POC thing and then copying it from there in the issue description over here. Why can't he just like directly type in over there? It's because in the description, there has to be a specific MIME type. Like to exploit this DOM XSS here, there has to be a specific MIME type to exploit it. The specific MIME type here is this one, text/xgfm HTML. So when this is the case, then only it will pass to the inner HTML, and inner HTML is gonna parse it and execute the DOM XSS. Now, to override the MIME type to this, what the researcher, in this case, Bobo Hello, he did, or she did, I don't know, just created this POC, and this POC, what it does is it sets the MIME type of the clipboard and then puts a value. So what this whole HTML page does is whenever the user sees this and they click on here, like in this case, click here, and click here does it basically copies the value. So by copying it, the MIME type is explicitly set to this particular MIME type, which is text/xgfm HTML. And because to exploit this issue, in this case, by clicking on here in the POC, the value is copied with that explicit MIME type, and when you paste it in the description here, it gets pasted like this. Let me go back. Yep. And if you paste it, it will directly get executed. You won't even see its value pasted over here. It will just go directly to the inner HTML in the div, and it will get executed and gives you the pop-up. So pasting content triggers arbitrary JavaScript code execution when the MIME type is this. And that's why this researcher had to go through all this process just to create that specific MIME type, which is the only condition to exploit this DOM XSS in this case. He created that HTML POC, spins up this whole GitLab thing and all, and then when you paste it and the value in the issues description, and because how this is processing it, actually there is a function. Let me show you. Yeah, paste GFM. So this is a function that takes the value when you paste something, and then it checks the MIME type. And if the MIME type is this, what happens? You know, that HTML happens and the XSS code gets executed in the browser. I hope this is making sense. I tried to simplify this thing for you. I'll put the link in the description so you can read it for yourself as well. Okay. Now we talked about how DOM XSS is, how you can look for it, and some few reports as well. And now let's talk about the DOM Invader extension, how you can use it. So again, for that, I'm actually going to use one of the labs from CodeSwigger. Okay, so I have this one lab here, and this is kind of like the most basic one, but we just want to understand how DOM Invader works. So as you can see, I have this extension here. You can install it as well, and it's turned on. So if I click on inspect, and over here we can see another tab, DOM Invader. Right now we don't see anything, but we do see a random string. So I'm going to copy this string. You'll understand what's the purpose of this string. Basically, you have to copy this string and put it in a field like the search box. So as you can see, I used this two strings before, but now I have a different string. It keeps changing. Okay, so you can put the string anywhere, like in the comment section or anything that is taking user value. You can also put this string in the HTTP request if you find any parameters while analyzing in Burp. So let's click on search. And we can see that we have one sync here. You can see syncs and it says 1. So it will show you a number of syncs that are found, but in this case it's only one, and it is document.write. And where it is being reflected, it is being reflected over here. Now let me go to elements. Actually, we already talked about this. We did the manual, right? We exploited this lab manually before, but I'm just showing you how you can do the same with DOM Invader. But if you just click on exploit, you will see the pop-up here, and you can see your payload here as well. So it's doing everything for you. It's creating the payload for you. It's finding a sync for you. So it's pretty easy, but I really recommend you to try this tool in different labs of CodeSwigger if you have already done all the labs with manual approach. Okay, so that's a really good way of approaching this, and this increases your chances of finding DOM XSS vulnerabilities while doing bug bounty hunting, as well, also reducing your time. So everything is same. This tool was just able to identify it by analyzing the source and finding where the sync is, and we talked about it. The sync is documented right here, and this whole thing gets up here in the page, this image tag, and but this search term has this value, and this value will contain our payload, but we already exploited it, right? With DOM Invader, pretty easy. Okay guys, that's it for today. I hope you really enjoyed this video and you learned something from it. Also, I want you to try DOM Invader in different CodeSwigger labs, then you will understand how it actually works, because it's not as simple. Just by clicking on exploit and you're gonna get everything. No, you should also understand how the tool is actually working and how you can make the most out of it. So if you have any questions, you can ask it in my comment section. And thank you for watching, and I'll see you in the next one.